Laser visual effects are essential for any video game like Zarya's laser weapon in Overwatch or the laser obstacles in Ori and the Will of the Wisps. So, as a response to one of our followers' comments, in this video we will show you how to create 2D laser shader graph in addition to all related particle systems. Also, we'll show you how to create the controls related to the laser itself, so to determine where it hits the walls and where to instantiate the laser particle systems, and how to determine the length of the laser line itself. I'm Ramiz Al-Tabba from Binary Lunar, and let's get started. Let's create the laser texture. Open a new Photoshop file with 512 on the widths and heights and set the background for now to black. Just create a rectangle, white rectangle with no borders. Then add outer glow, layer effect, rasterize the rectangle so we can use the smudge tool on it. Now use the smudge tool to create something like a flame moving to the right. Keep doing several flames which will represent our laser. And what matters in the end that you keep the thickness of the end of the laser same as the beginning of it, so it can do a looping when we move the laser texture. Then use the eraser tool to create some spaces inside the flame. Then apply the smudge tool again on the black areas to make them blend nicely with the flame. You can also create as many as you need or you feel it's good for your texture from those. So create some more additional spaces. And finally remove the black background and save the file as PNG. Now create new Unity 2D project, drag the PNG to project files and set the wrap mode to repeat. Add the universal RP package from the package manager. Now create a new pipeline asset forward renderer and rename it to 2D renderer, then set that as a default in both graphics and quality in the project settings. Now click on the 2D renderer and enable the HDR so we can be able to create the bloom post-processing effect later. Now let's create our shader. Create sprite unlit graph. Let's name it laser shader, then open it. Create a new property, texture 2D, which will represent our laser texture. Then drag that to the shader and link it with 2D sample texture node. Then link the sample texture 2D node to the color at the master node. Now we can see our laser texture, and the idea here is so simple. We need to move the texture on the x-axis to make it feel like it's moving laser. So let's create a new node, tiling and offset, to control or offset the texture, and link that to the UV on the sample texture 2D. Now we need to move the texture during time, so let's create time node, then multiply it with a new property, vector 2. We can call it laser texture speed. Drag that property to the shader, then multiply the laser texture speed with the time to move the texture by linking the multiply result with the offset. Set the default speed value -3 on the X to make the texture move to the right. Save the shader, then go back to the scene. Now we will use the line renderer to visualize the laser. So create a new line renderer. We will apply the shader graph as a material on the line renderer. So we need to create a new material. Let's create a new material, name it laser material. Then drag the shader graph on it, then drag the material to the material field in the line renderer. If we clicked play, now we can see the laser is moving in the scene. Let's change the camera background to black, that will make the glow more visible later. And also let's apply a gradient to the line renderer, that will give a nice colors to the laser beam. Now let's add the bloom post-processing effect by enabling the post-processing on the camera, then adding the volume component, add a new profile, then add the bloom post-processing. But as you can see, even if we enabled the threshold and the intensity and played with the values, still we can't see the glow yet. And that's because the line renderer colors are not HDR colors. To enable this feature, we need to add to our shader graph a new property, color, and enable it as HDR. So let's create a new property, color property, and set the type of the color to HDR. Set the color to white and increase the alpha to maximum. Then drag the color property to the shader and multiply it with the sample 2D texture. Then link the results with the color in the master node. Now setting the threshold to 0.3 and setting the intensity to 5 will give us a nice glow. Now to remove the sharp edges at the beginning and the end of the laser line, we need to create a layer mask to cover the edges nicely. So I created a new texture in Photoshop just by doing a linear gradient, which starts from transparent and ends with transparent and between to be clear white. Remove the black background to get transparent layer mask, then save the file as PNG. Now go back to the shader and add 2D sample texture, assign the texture of it to the layer mask we did, then multiply it with the sample texture 2D of the laser texture. Save the shader and now you can see nice smooth edges of the laser line. If you are planning to move your laser line, you need to uncheck the use world space. Now as a final thing we need to do to our shader graph, we need to add a distortion, a moving distortion, which makes the laser more like living or more eye attracting, because now it's just a moving texture to the right. So adding this distortion will make our laser more interesting. So let's create a simple noise node and we can control its scale by adding a vector 1 parameter, name it the noise scale, and drag it to the simple noise node so we can control the scale later, and set the default value for now to 20. And as we did for the laser texture, we need to move this but at different speed this time. So let's use a tiling and offset node, then use a time node and a vector 2 parameter to control the speed of the noise. Do the same, multiply the time node with the noise speed, then link that to the offset, then link the tiling and offset to the UV of the noise texture. Now we need to mitigate the noise strength, and we can do that by creating a new parameter, noise strength, and multiply that parameter with the power node to control the strength of the distortion, and set the default value to 0.1. And finally add that to the tiling offset, then link the results to the UV again of the laser texture. And now we can see nice distortion effect has been added to our laser line. Then after experimenting a bit, I found that setting the laser texture speed to -2 and setting the distortion speed to -1 gave the best results for now. Now let's create the particle effects, which will be shown when the laser hits a wall or something. And to facilitate doing that, I provided a link for sparkles brushes for Photoshop, which will help you create the material for those particle effects. So just download those brushes, use any one of them, create a texture out of it, save it as a PNG, then go back to Unity. Then we need to create a simple shader graph to render those particles. It will consist only of two nodes, one for the sample texture 2D of the particle texture and another one to control the color, and we multiply them, then link it to the color in the master node. Let's create the material for the first particle system. Let's name it sparkle material, then drag the shader graph we created on the material, then assign that to a newly created particle system. Set the start lifetime to 0.1, set the start speed to 0, and set the starting rotation between two constants, 0 and 360. Remove the shape property because we want the particles to emit at its place without moving. And set the initial size to the start size to 2. Enable the size over lifetime and make it double its size during its lifetime, so it suddenly goes from 0 to 1.5, then it settles to 2 during time. Also enable the color over lifetime and make it a change, for example, from something reddish to something bluish, and make it in the end become transparent. And finally increase the start lifetime to 0.1 to get this nice laser hit particle effect. To make this more juicy, I added another particle system as a child to the first particle system and make its particles collide with the world around it, so it can collide with the walls or the ground, which make it realistic. So I changed the emission shape to circle and flipped it 90 degrees on the X to make it face the camera, adjusted the start lifetime and the start speed, and the main thing here to add some gravity by changing the gravity modifier to 2. Changed the color to orange and changed the render mode to stretched billboard. Also the length of scale made it 3. That will make the particle rotate based on the velocity and the direction they face. And finally I added collision with the world and changed the mode to 2D. You can keep the collision with everything or specify which layers you want particles to collide with. Then I added a ground by creating a square, stretching it to be a rectangle, then adding 2D box collider to it. But as you can see now, I didn't set the bloom post effect correctly, that even a color without any intensity is glowing much. So let's add intensity to the laser and correct the bloom effect parameters. So let's go to the colors of the particle system and increase the intensity to 2. Also go to the line renderer and change the color intensity for it to 2. Then go to the camera and adjust the threshold to 1 and the intensity to 1 too. That will fix the glow and make it looks better. And of course, to make the second particles to glow, we need to create a new material for it using the particles shader we created, so it can support the HDR colors. So in Photoshop or in any other program, just create a radial gradient from white to transparent as a texture, then create a new material and apply our shader to it, apply the texture and change the color to what you want and increase the intensity to get this nice glowy effect. We can now just change the size to make it more suitable. Then I added box collider to the ground and made a copy of it to create a wall on the right. And now the particles can collide nicely with the wall and the ground. We just need to decrease the bounciness to 0.5 so it bounces in more realistic way. Then I created another particle system for shooting the laser. It's the same process as creating the laser hit particle system, so I'll be fast forwarding here. I just only changed the brush I used for the texture and that's it. All the steps are the same. And to make the laser looks even better, I created additional particle system as a child to the start laser particle effect. This time I wanted to make the particle system as we really emitting laser from the beginning of the laser gun. I nearly did the same step to create the second particle system for the laser hit with some minor changes. The main changes are here the following. The start speed is minus 1.8 and the emission to 70 and the shape to be a cone with an angle around 36 and a radius around 0.01, and of course change the rendering mode to stretched billboard and increase the lens scale to around 10. Now we're ready for coding. Just place the laser particle effects as a child for the laser game object, so it moves all as one game object. And to make things more logical, I brought a laser cannon weapon sprite from the internet. I'll provide the link for that in the description, so it feels like this laser cannon is shooting the laser itself. And place the laser game object inside the laser cannon to be a child of it, so we can move everything as if the laser cannon shooting stuff. Let's add an audio source, and I recorded a laser sound effect by my voice using voice mode. Then let's create the laser controller script. In this script we will need references to our particle systems, one for the laser start particles and one for the laser end particles, a reference for the audio source when we shoot the laser, a reference for the line renderer to control the length of the laser line when it hits walls. We also need 3 bools, one to check if we are playing the sound effect of the laser, one to check if the start particle systems are playing, one to check if the end particle systems are playing or not. And finally we need a raycast hit 2D to get the location of the raycast hit. Now in the update function we check if the fire 1 button, which is the left mouse button, is pressed. We check then if the start particle is not playing, we set that bool to true and we play the laser start particles, and we pass the parameter true. That will let any child particle system to play also. Then we go to the game object which holds the laser start particle and set its transform to the transform of the laser itself, which is the beginning point. And we enable the line renderer. Then we check also if we are not playing yet the sound effect. We set the bool to true and we play the sound effect as a loop. After that we do the raycast, but we forgot to add 2 additional variables, one float to determine the length of the raycast, and second one the layer mask, which will determine which layers we will be detecting. Based on that we check if the raycast detected a hit. Then we check if the end particle system is not playing, we set the bool to true and we play the laser end particles. Then we calculate the distance between the hit point and current position to calculate the length of the line renderer, and we set that using the line.setPosition of the point 1, which represents the second point in the line renderer. Else, that means we're not detecting a hit, we return the line renderer length to its normal length, and we set the ending particle playing bool to false, and we stop playing the laser end particles. Else, which means that the player is not holding the fire button or just released it, we return the line renderer to its default line length. Then we disable all the particle system and we set all the bools back to false, in addition to stopping the sound effect and set its bool to false also, in addition to disabling the line renderer. Also, I just noticed that I forgot to set the laser end particle position to the position of the hit when we hit the wall. Save the script, then link the particle systems in the inspector, then set the layer mask. You can set it to everything or create new layer mask, name it ground, and make that the layer for the ground and the wall, so it can detect only the collision with the walls. And finally I added player movement script to control the laser cannon, and added the box collider 2D and rigid body 2D, of course. If you want more details about how I did that, there are tutorials we did before. I included the link in the description and you can click on the link on the top right corner. And that's it, we created visually stunning laser shader graph with all its related particle system and learned how to control the laser by code. Thanks for watching and thanks for our Patreons. Anurag Clancy, Benjamin Schmeidet, Benjamin Venji, Craig Anderson, Jack Crystal, Rick Jakubowski, Zachary Fox, and Mohammed Aiden. Don't forget to subscribe so you don't miss the next videos. Till next time, see you soon.